So here we have constructed a graph object with 6 vertices and we have added 9 edges to this graph object. And then we have invoked a function called shortest distance on this graph object where we are passing the source vertex. So this is the function that we are going to create to find out the minimum or the shortest distance of each vertex from the source vertex. But before that, we're going to construct this class called graph. So let's create the class. Let's create it here. Let's say graph. And now in this graph, we are going to take constructor where we will pass the total number of vertices. So here, let's say this dot edges equals to the array and this dot vertices, total vertices equals to total vertices. So here we are having an array called edges where we will store all the edges for this graph, and to add edge we are creating this function add edge in this class graph, in which we will pass the source vertex, the destination vertex, and the weight of that edge. So total possible edges is equals to this dot total vertices multiplied by this dot total vertices. That is, the number of possible edges cannot exceed the square of number of vertices, right? So here we can write a condition that total possible edges and total possible edges, we have value in total possible edges, and this total possible edges should be greater than this dot edges dot length, or you can say the length of the edges array or edges list must be smaller than total possible edges. So then we will push this edge into this edges list. So here we will construct the new edge. Let's create this class new edge and let's create this class. So class edge and constructor. So as we know, edge will be having values source, destination, and weight. This dot source is source, this dot destination, this is the destination of the edge, and now the weight of the edge. So this is the complete edge object, which is constructed using source, destination, and weight. So here we will pass the source, destination, and weight of the edge to construct the edge object, and then we are putting this edge object in the edges array. So this is how we will add each edge into this graph. And now coming to the implementation, let's implement the function shortest distance, and here let's pass the source vertex. So here we are going to take a distance array that will hold all the distances of the vertices from source, and it is of size this dot total vertices. And initially we are going to fill all the cells with max integer, which we are considering infinity here, and the distance of source to source is obviously 0, so we are setting it to 0. And now we are going to relax each edge for n-1, or you can say for v-1 time. So this for each is for that, and now here inside this for each we are going to again invoke for each on the edges list. So edges dot for each. So for each edge we are going to do this stuff. We're gonna take the edge and now we are going to get its source vertex, which is u. So this will be edge dot source, and now the destination vertex, which will be v. So this is edge dot destination, and the weight, which is the cost here, c. So edge dot weight. So we got the values of u, v, and c. Now we will apply the Bellman-Ford formula. So here we will check if the distance from source at u is not equal to max value, that is infinity. And now comes the formula that if the distance at u plus the cost or the weight of the edge is less than the distance at v, then we can update the distance at v as this sum, that is distance from u plus the cost or the weight of the edge. So this gonna get done iteratively for all the edges and for n-1 times. And after this, we will be having the shortest distance of each vertex from the source in the distance from source array. But even after the execution of this implementation, still if we apply this formula on any edge, and still if we are able to get this value distance from source at u plus c smaller than the distance at v, then obviously the graph contains negative cycle. So here I have copied this for each on edges, and here we are checking if still the distance from source at u plus c is smaller than the distance at v, then the graph contains negative cycle. So we are just going to log this graph contains negative cycle. Now this implementation is complete. So here we are going to return from here because we are not going to do anything after this. But if the graph does not contain negative cycle, then we are going to print the result here. So we're going to apply for each on this distance from source list, and we will print, or we will log console.log the vertex and its distance from the source. So it's done. We are already invoking this function, so we're not going to invoke it again. And now we will run it. So let's say node Bellman-Ford, and here these are the shortest distance of all the vertices from the source, that is from the vertex 0.